Hello there! Let's take a look at collision theory. Ah, atoms. As tiny as the amount of work I have to do. Wait, it's opposite day, right? It doesn't matter. Let's dive right into it. Speaking of diving, if you look at the chemical name of water, H2O, you might notice that they have two chemicals on it, hydrogen and oxygen. We're not talking about the Mermaid TV show here, but the thing you are 70% made of. As the name might suggest, H2O has two atoms of hydrogen and one atom of oxygen. But oxygen usually comes in pairs, doesn't it? So, how is there only one atom here? The answer is simple. There was a reaction. When it rains, for example, that reaction happens. Isn't it beautiful? Just nature doing its job. It isn't always raining, though, is it? Well, why isn't it raining all the time? I wouldn't mind, during quarantine at least. It could always help to keep people inside. The answer, I think, is that there are no conditions for such things to happen. No, you can't just put a toast on a toaster and wait for magic to happen without turning on the toaster. Okay, rain is lovely, but let's leave it where it is. Take this example for us to start studying collision theory. A quite reactive one, just for fun, lithium and water. This isn't the best example at all, since lithium reacts really easily, but let's suppose it doesn't. For lithium and water to react, they need to have a certain amount of energy when they collide, because atoms are always moving. Even though they don't seem to be moving, they are always colliding with each other. And when lithium atoms collide with water molecules, that should do the work, right? Yes, but not exactly. They still need to have enough energy to start the reaction, and what defines the amount of energy they need is the activation energy. It's very easy to show it to you on a graph, so I'll try to draw one. So, as you can see, here's the graph with the line that represents the activation energy. The activation energy line can be lower if the factors are more optimal for a reaction to happen, or higher if they are far from ideal. But again, lithium reacts really easily with water, so we'll leave the line there. Now, if the energy the atoms have when colliding is superior to the required, the reaction will happen, giving us lithium hydroxide and hydrogen. If it isn't, well, nothing happens, and they just bounce back. Oh, and the angle actually needs to be right too. If for some reason a lithium atom hits a certain part of the molecule that is not good for the reaction to start, it just bounces back as well. But the reaction isn't that unlikely. Remember that there are millions and millions of atoms in the reaction. So, we've talked about activation energy and that it could change according to its factors. But what are those factors? Well, there are four main factors here, which are temperature, concentration, surface area, and the presence or absence of a catalyst. Temperature increases the energy and it makes the atoms move faster, increasing the frequency of collisions. That leads to a high chance of the reaction to happen, and it speeds up the reaction in general. Then we got surface area. So here's a question. You're about to eat your mom's spaghetti bolognese and you want to put some cheese in it. You have a good taste, by the way. Anyway, do you use shredded cheese, or do you just put a huge block of cheese on top of the delicious meal? I'm assuming you do the former. I hope you do so. It spreads the flavor of the cheese, and it makes your meal richer and tasty, unlike a huge block of cheese in the middle of the plate, which is just dumb. How are you even going to eat that? That's surface area to you. Now, in chemistry terms, surface area has a different purpose. It makes more atoms exposed to the outside, allowing more collisions between, in this case, lithium atoms and water molecules, and boom, explosion. At least it's more likely to happen. When you have a huge block of lithium, though, you actually have less surface area than when you have several pieces of it that add up to the same mass. Interesting, right? Then we got concentration, and please focus on this one, which consists of the number of particles per unit of volume. It increases significantly the number of collisions, thus making the reaction faster. Finally, we've got catalysts, and they aren't as essential, but they do speed up the process, which get the reactants together faster. If you are in biology, you might have heard of enzymes. They are biological catalysts, which speed up the process of digestion, for example. Well, this is it. Hope you enjoyed the video on collision theory. I'll see you in the next time. The answer is simple. And water. This isn't the best example at all, but since lithium reacts really easily, and water to react, they need to Finally, this will be useful. You're about to eat your mom's spaghetti bolognese. Speed up the process, which get the reactions together. What the heck did I just say? Speed up the process, which get the reactants faster.